Hello and welcome to the Infrastructure Domain session as part of the buildingSMART International Standards Summit in Lillestrøm 2023. Thank you for joining us today. My name is John Proctor and I am your moderator. Today's session details are showing on the screen. This is the third session from the Infrastructure Domain, the IFC for Tunnelling team. The project lead, Michel Rives, will be introducing the session, and we will be hearing from his team, including Andre Borman, Stefan Joud, Sergej Muhik, Mickaël Beaufils, and Lars Wikstrom. We also have videos and slides, so we got a full interactive session for you today. We're going to last for 90 minutes, including hopefully some time for questions at the end. The session is being recorded and will be made available in the replay section as soon as possible. Before I hand over to Michel, I'd like to remind you that this is a hybrid event. For those of you online, your microphones will remain muted for the duration of the session. If you wish to make a comment, please ask any comments or raise any questions in the comments box, and I will prompt you to do that during the session. For people in the room, please keep background noise to a minimum. And if you wish to make a comment or ask a question, please raise your hand and we'll use this microphone. I also need to make you aware of the information on the screen now, that buildingSMART is committed to ensuring that participation in the development of standards is unrestricted and the process for their adoption is transparent, and that standards that are developed do not favour any particular provider but are open, non-binding and accessible to all. Please note our antitrust code of conduct. With that, I will pass to Michel.
Thank you, John, and hello, everyone. Thank you for being here, spending your time with us this afternoon. We have a packed agenda, as John just said. Maybe just a word of introduction myself, if you don't know of me already. I'm running a company called Vianova France, and we do BIM management on many, many infrastructure projects worldwide. And I'm honored to be the project leader of this terrific team that is developing the IFC for tunneling, which covers geotechnics, excavation support, and the systems that allow for the operations of the underground structures. The agenda looks as this. I'll be giving you an update on the scope, our milestones, and where we stand with the engagement of the software vendors that have decided to work with us on developing those extensions for the tunneling industry. And as you've understood, those extensions will make up the IFC 4.4 release, which is the next release after 4.3 that has just been resubmitted to ISO. After this, Lars will give a more detailed presentations of all we have developed over the past 2 years. And that encompasses the conceptual model, the HTML documentation that is available, the express schema that we have that go with it, and basically the way we've been interacting with software vendors in order to develop those extensions a way that is for them the easiest to implement. So that was really a both ways interaction with software vendors so that we can come up with something that was as easy as possible to implement into their existing professional software solutions. We'll have an update on behalf of OGC, because this project, for at least the part that concerns geotechnics, we do drive together with OGC representatives. So Mickaël will be showing to you the way OGC takes this work that we've developed in common on the OGC side to implement. Likewise, we do on the IFC side, they do on the OGC side. And last but not least, we have some special guests today. Our friends from CCCC will be giving you a brief update on their plans for something that will come naturally as an extension to what we've been doing, but in order to cover emerged tunnels, which is a subject we have not covered yet. And last but not least, we have a video that compiles proofs of evidence of the work that software vendors have been doing in terms of implementing those concepts. Although the norm is, the standard is not officially published yet, but still, since we've been working with those software vendors, they've started implementing these concepts into their export-import capabilities. So that be proofing you what they have already achieved, and that's a very serious proof of their commitment towards developing a standard for this tunneling industry, geotechnique and tunneling industry. Am I still in a display mode? I am now, right. So just to prove you how seriously this team takes the subject, where some teams, gather around, it's no problem. They gather around a glass or two at a bar. Well, we decided to gather at a construction site. So thanks to Jan Erik, we could organize yesterday a visit of a tunnel construction site, major ones nearby Oslo. And so the team can, get a sense of how practically things can get when it matters to inject into those drilling machines data that comes initially from early design to detailed design to construction design down to the machine on site, and then recollect what has been excavated back to the central database where you can compare as designed and as built, right? So the team got a sense of this, and even feels more the importance of doing things right, if I may. Right, so for those of you who would need this little update, what we are doing with this IFC 4.4 release is actually twofold. One, we extend the infrastructure domain by covering everything that is underground structures related. And number two, we act a bit in a transversal way, whereby all those extensions for geotechniques will help, of course, the tunneling industry, but will help the building industry when it comes to deep foundations, will help the bridge industry when it comes to deep foundations, and will help the roadway and the railway industry when it comes to earthworks and any measures that go around reinforcing soils and so on and so on. All right. So truly, this is like a transversal and a domain-specific effort. So once done, it will follow the same process as 4.3 with the pass over to ISO for its norm publication as the norm. One thing I want to stress here as well is the importance, of course, of those who, from a domain perspective, contribute intellectually, but financially as well. And I want to stress the importance, of course, of the financial support on behalf of SBB, who is today, at the end, the major financial contributor. Our friends from Trafikverket, the Finnish tunneling administration, the Norwegian, thank you, Finnish association, Lombardy Group, who am I missing here, and the Sequent Bentley Systems team. So these are the main financial providers of the project. But basically, we have representatives from all over the world. And one thing I want to stress here is the fact that we've set up, besides this relationship with OGC, we've set up from the ground up a relationship with the ITA organization, the International Tunneling Association, which gives us a view from an end user perspective. They don't know anything about IFC, but they know how data structure matters when it comes to, of course, construction sites. And they are passing over now recommendations in the different local branches of ITA. So in all the countries in the world, they are passing recommendations for the use of IFC when it comes to exchanging information that relates to tunneling projects. So that's a key way to convey the message on a worldwide basis. Now, getting into the scope of what we've been doing, as I said, first part deals with geotechniques. And with this, we are to deal with things that basically you do not know before you start excavating. So you do boreholes, you do observations, you do laboratory tests to sort of make a potential, assumption of what the soil might be. So therefore, you need boreholes, you need observations, you need factual data. Once that is captured, you build up an interpretation of this information to create an interpreted model. It's not an interpolated model, it's an interpreted model, which means that the geotechnician injects his knowledge so to interpret the data and make a possible situation model, interpreted models. And then this model is meant to be used on the design side by the civil engineers to to optimize of course, the layout, the alignment of the tunnel, and decide upon the excavation methods and the support methods depending upon the soil situation that is effectively encountering. So we agreed upon that. We organized data that way, and we decided as well to make sure we don't forget to offer the opportunity to link with external data, like, for example, AGS data or DIGS data, AGS being used in the UK, mainly DIGS being used in the US, so that information that is relevant to observations and boreholes be maintained in that format, but we would be linking our information to these formats. That was the first part. The second part has to do with excavation and the structural aspect of the tunnel itself. So, for example, to start to organize data the proper way, we decided to identify the areas, the volumes, if you will, that either relate directly to the excavation that has been realized, the support structures that have been created, and the lining processes that have been used. That's the first category of quote concepts. And then the third category of concepts relates to this idea of, because we are in a very constrained environment, relates to the spaces, the reservations that needs to be made so that they can host the different systems that allow for the operation of the tunnels. So that's to classify the different concepts. This is what we used and agreed upon. That's the second part. Then within that, we took into considerations as well the way the tunnel itself was realized. So either through a tunneling boring machine, TBM, or through the classical drill and blast approach, which we visited last night, or cut and cover structures, which in a sense the emerged tunnels derive from, but it's a bit different. But it's a prefabricated sets of concepts and objects. And last, of course, relates to the different systems that equip a system. So the scope of what we've been doing covers all of these domains, the objects, the properties that relate to those objects. So it's quite, of a large scope in a sense. Time-wise, what I'm just referring to, we've done until the end of last year, 2022. And since the beginning of 2023, we started actually show-proofing the quality of what we had designed, quality proofing, I should say, the quality of what we had proposed with software vendors. So, and of course, everyone speaks from its own perspective, given what its own authoring tool can do, and so on and so on. So that was an interesting mix to find out whether we were rich enough to cover all that those different authoring tools do manage. And it looks like we are pretty good when it comes to that coverture. And so that exercise we ran with 20 plus product teams since the beginning of the year. And the idea of this session here is to report upon the progress on behalf of those software vendors that we support, and give them the opportunity to, again, show proof what they've been doing. The process for developing the deliverables of this project are, the ones as per the BSI processes. But basically, you've understood we've captured the domain requirements. We've created different taxonomies. From that, we created data requirements. From that, we developed a conceptual model. Again, this part is something that we've been sharing with OGC. And with their input, of course. And there was this team, but relayed by other experts. We've created a conceptual model per se, the documentation that goes with it, and then the extensions themselves. Lars will be covering that more in detail just to give you a sense, but basically we depend upon this GitHub platform whereby the software developers find examples. We provide example files so that they can basically copy-paste how a concept should be implemented, should be used. And this is very efficient a tool, I think, and that addresses the software vendors' expectations. So on the official BSI website, you can now find a web page that relates to the proposed 4.4 extensions. So it's a candidate. Well, it's a draft at this stage. It's not exactly officially a candidate yet, but very soon. But basically, you will find out all the entities that we are proposing. Altogether, that must be of around 300 something entities and properties. So as an extensions to 4.3. You can visit that website and you get all the information with the documentation of what this concept is meant for, what the properties are, what's the definition of those properties, and so on and so on. So this is really as per the buildingSMART quality process for developing an extension. Okay. One little thing I just want to stress, if you haven't seen this, but I would assume that it was already showed that. It's the way IFC are organized today. So by layers, so you know, from deep to domain. And we mainly touch the domain area, of course. But once developing the 4.4 extension, we needed to keep track as well of what was done on the 4.3, because 4.3 kept improving until the last submission in early September to ISO. So we need to make sure we keep track of those improvements. And likewise, we have prepared a series of improvements on the concepts that we share with 4.3. So for example, in our project plan, we are at the end where we start dealing with really domain-specific stuff. But in the past 4 months, we've been dealing with concepts that are common to anyone willing to prepare an IFC exchange. Right, so we did cover one by one those concepts, and we did show all the software vendors how to implement those concepts one by one. Again, some of those software vendors were very well aware of IFC because they've been in that space for years. But we have also, as well, software vendors who come from the GIS space, and these people were not. They were aware of the OGC side, but not so much of the IFC side. So we need to really take them concept by concept to make sure they understood. That is a dashboard of the progress made by the different software vendors. So you may be reading the software vendors to the left, and their progress in terms of implementing the different concepts and the way they passed the quality checks that we offer them. So they basically submit a file and say, okay, I've implemented that. Is that good or is that not good as per the specifications that were produced? And the checker says, okay, well, good, not good, not good, and then another iteration. So that's a tool that is really convenient for them to support to support the quality development process. And just I mentioned earlier, we are dealing with, of course, software vendors who provide authoring tools, so design tools in all those domains. But we have as well companies like Beaver Control or Renknecht, who are builders of providers of drilling machines. So it's important we have them on board because they can, again, send the data to the drilling machines. We have BIM collaboration platforms, and to some extent, we have as well assets management solutions. And of course, there is the core library providers like ODA, RDF, Geometry that inject as well those extensions into their solutions. Schedule-wise, that's the traditional BSI process. So we, at the end of the year, were somehow ready with a draft standard, and we are challenging it with the software vendors, as I said, since the beginning of the year. We have a candidate standard in our pocket. Now we needed to, before we go into the final standard, we needed to go into another milestone, that is the dependence we have on 4.3, because 4.3 has been resubmitted to ISO, as you know. We hope to get the official check by ISO by the end of the year. And so what we need to do is make sure that we re-inject the 4.3 baseline into our 4.4 development, which creates a dependency. But basically, we still shoot for a candidate standard by the very beginning of 2024, and then should start the ISO process per se, which typically would take another three months or so. But the challenge for us, of course, with this submission is to make sure that we are now aligned with the quality expectation expressed by ISO at the occasion of a rejection of 4.3 and our resubmission. So it's a challenge for us, but at the same time, we hope we've been, doing the quality work ahead of this submission, so that we feel good at the time we will be submitting. So now I'd like to pass over to Lars for a bit of a more technical presentation. And after Lars, Mickaël will be presenting the OGC implementation, after which we have the CCT team present to us their plans in terms of immerged tunnels, and then this little video that I was referring to. Lars, the floor is yours.
So if you want to just introduce yourself, Lars, we'll just move the slides across.
Yes. Hello, everybody. Lars Wikstrom from Sweden. And I've been working since phase 2 of this IFC tunnel project. So the requirements analysis was already done. So we started to work on the domain concept and conceptual model, and now deployment project. And I've been doing this together with my colleagues, André Borman, Sergej Muhic, and Stefan Jaud, some of which I think are in online here. So I think Michel already told you maybe what most of you already need to know, but a little bit more detail on this. So when I came in, we had already an IFC tunnel requirements analysis. And the domain teams, the geoscience team and the systems team and the excavation team, they started to work then on these large Excel sheets with domain concepts organized as a sort of taxonomy. And from there, we did essentially the same thing as we did earlier in the IFC 4.3 for road, rail, and bridge and ports and waterways. We created an UML model, a conceptual model, from which we can generate a couple of reports, which are already available. And then based on that, we developed the actual IFC extension with the express schemas and the concept templates and everything that is required for the specification. So we actually had then 3 domain teams, and you see them here. Geotechnics actually divided into 3 parts. Book A, about the factual data that Michel mentioned. Book B, the interpretations of that. And then Book C, which is the design-related data, sort of the intersection between sort of the pure geotechnics and the design. And then we have the excavation support and lining team with excavation, ground improvement, waterproofing, pre-support support, and lining, and also some interior stuff in the tunnel. And finally, systems with earthing, firefighting, drainage, power supply, etc., etc. And I would say out of this, the systems part actually, most of the stuff that was required already exists in the IFC schema, I would say. But regarding the other 2, we actually had to create new entities and predefined types in the schema. I think I will skip this part. For the UML models, for those of you who are interested, we actually use the same guidelines for creating that as IFC 4.3. So the color coding and everything is the same as we used for road and rail and so on. So, and I will skip that as well. So the conceptual model reports, you will have 1 report for each of the domains. And they are structured in the same way, and in the same way as the reports were structured for road and rail and so on. So you have actually five reports, 1 for systems, 1 for excavation, 1 for geotechnics, 1 for the IFC extension. I mean, everything that we actually had to create as an extension to IFC, we put that in a separate report. The systems, excavation, and geotechnics essentially describes the mapping between the domain concepts. I mean, the stuff that we got in Excel from our domain experts. I mean, they have their vocabulary and structures that they use. And out of that, we create a UML model, and these reports actually describe how we sort of interpreted their domain concepts into a conceptual model. Yes, and based on that, we have developed then an IFC extension for tunneling. And now we are in this, you see, sort of iterative phase of deployment, where we work together with all these software vendors. And I would say that the main purpose of that, I mean, there are several purposes, but main purpose is to actually validate our schema extension and that it actually works. But as Michel told you, it's also a matter of actually sort of getting the software vendors on board, and some of which maybe never implemented IFC before. So we actually had to start from the really basic structure of IFC. What did I have? Yeah. Now in the deployment part of the project, we are also now developing property sets, and lots of them. So we are actually in the middle of this, but this will also become part of the specification. So I think I have a slide somewhere on the status. Okay, so this is first the process for developing property sets. Property sets can seem like a simple thing to do, but it's quite a tedious work actually. So we work with the same domain team, systems, excavation, and geotechnics, and they have specified again from their needs lots of property sets in Excel again, and we process that actually in an automatic fashion, where we produce pull requests into our GitHub environment, where it can be reviewed and approved, and when it's approved, it's included in the sort of new iteration of the specification. And hopefully I can show a little bit, if there is time, I can show you live from GitHub. But first, so the status for the properties, just to give you an impression. So geoscience, we started with that. A lot has been already merged into the specification, but some work still is ongoing. Excavation, we have also started. Certain things are already merged into the specification, and certain things we are still sort of negotiating between the technical team and the domain team. And I'm sure she remembers the work in IFC rail and road, and I mean it's quite tedious work actually. Yeah, and also systems. We have got sort of a first iteration from the domain team, and we have started to process those as well. Yeah. So that was essentially what we do to develop the schema extension. And now to explain a little bit more how we work together with the software vendors in this deployment process, we actually have set up a GitHub environment, and you actually see the first page here. And in there we have all the recordings from, we have support calls every Thursday in the morning and in the evening, together with the software vendors, and they can sort of bring up any issues or questions they have, and we can discuss it there. And everything is recorded. We have files, that is all the files that the software vendors produce, they can push up here, and the files are automatically then tested. And they are actually tested to what you have inside sprints there. We have actually divided the project into 3 sprints. First, a very basic sprint where the software vendors can learn how to sort of create the backbone of an IFC file with a simple project structure, set up the units, do the necessary declarations and so on. And then we build on that. And now we are actually in sprint 3, where we are dealing with then tunnel specific concepts. So we have sort of one thing builds upon another. Yeah, so it essentially works like this. We have sprint requirements, and I can show you what they look like. They reference directly to the specification, where you have the entities, predefined types, property sets, and you have also concept templates and usages. And we base our requirements on these usages. So we specify you should use this usage and put in these values and so on. So they should know exactly what to do. The software vendors, they export data and push it into the GitHub environment. And we have then some software doing automatic checking of those files, and you get a report on if it's okay, or if something is wrong, you will see what is wrong. And when approved, the pull request is merged. And of course, also an outcome may be that something maybe is wrong in the specification. So it can generate an issue in the specification repository instead, of course. Yeah, I already told you this. I can show you live later. This is an example of requirements for a certain sprint then. So these, you see spatial composition, decomposition, alignment layout, and so on. Those are actually direct links to the concept templates in the specification sheet. So you can click that and see exactly the structure that you need to implement. And beneath those, you see the actual requirements that sort of is connected to that particular concept then that we are testing. And of course, then the checker software, which is behind this, checks exactly according to this structure. And yeah, as I said, the spatial composition, for example, here is a link, and that links directly into the specification where you see exactly the structure that you need to implement as a software developer then. We also have the FAQ page where we have direct links, for example, to the specification, to the express schema. Since we are doing this iteratively, I think we have had at least 3 incarnations of the specification of the tunnel extension. So they need to have links to the recent one, the one that we are actually using right now, and they get this from here. Yeah. And this shows just when you have pushed a file as a software vendor to this GitHub environment, you get a direct feedback on how you succeeded, and you can click this summary button and you will enter the actual report of the verification of the file. Yes, Michel. 5 minutes. Yep. Okay, so I think we will then go live. just showing you a few.
You want to do GitHub?
Yes.
Yeah. Okay. So we're gonna try and show GitHub. Lars, as you are doing, if you go into the system on your laptop, we'll then transfer across. This may only work for people in the room, but we'll show people online Lars viewing GitHub through the camera, and no doubt describing what he can see there.
Just to re-stress what Lars has been saying, that is of importance, is that through this collaboration via this GitHub platform, we get as well requests from software vendors that say, are you sure about that definition? Are you sure about that specification? Are you sure about this value range for these particular properties? Because in our software, blah, 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 or given our customers' database, we know that, blah, blah, blah. So we have refined different areas of the schema based upon the feedback of those software vendors. So it's really a win-win thing, and very efficient, actually, a tool.
Just to show you how we work. But yeah, Mike, sorry. This is an example of a pull request then for a property set that has to do with geotechnics. And you see we have sort of generated some markdown for the domain people that know the domain, so they can see that we have actually interpreted what they needed. And then there's a lot of discussions here where you see G. Weil, that's the leader of the geotechnics domain team, is participating in the discussion. And we get some references to some standard somewhere, which they are actually referencing. And we have this extensive discussion. And after we are done, we end up in the specification where you actually see the real result of it. So after we had this discussion, we all agreed, and the pull request was merged into the specification, and we generated it here. I also, one more thing, I can go this way, I think. This is then the deployment GitHub, and if we go down into files here, you see the different folders from the different software vendors, and beneath here you have their files that they have submitted for different sprints. And I actually wanted to show you this one. I think that this was especially interesting how it actually works. So this is from Ivar Oppen, that's Beaver Control, and he uploaded a file. Let's go down here. And you can see the result here, where the representation was considered wrong by the checker, and also the excavation entity was not correctly implemented with regards to the spatial structure. But Ivar actually felt that this was wrong. He thought he had the correct geometry. So he actually had a discussion with Stefan, and the checker was fixed as a result of that. And also just showing that they are very active. Now that has been closed already, but we have an example where Stefan made a fix and he wanted Ivar to check it, and it took, actually you could see here, it took 2 minutes from when Stefan actually uploaded a fix until Ivar approved it, so we could, it's a very fast process. So I think I will have to stop there.
Thank you, Lars.
Thank you.
Your sentence is of importance. In that particular case, it was a software vendor who validated what we had developed for the checker, yes. which is good. You know, it's a both ways thing again. And I think this is really bringing the quality that we were looking for. So the next, thanks very much, Lars, again, and you know, all the work you do, you, Stefan, and Sergey, behind the scene. That seems easy, but this is a lot of work. Next speaker will be online, Mickaël. Mickaël, can you hear us?
I'll bring him in.
Okay. So Mickaël is from the French Bureau for Mining and Geology. He's a data architect, and he's been helping us conveying the expectations on behalf of OGC, both from a domain perspective and from an implementation perspective, and he's driving this implementation on behalf of OGC that is called the Geotech IE initiative, which is meant to ensure the deployment of this common conceptual model that we have developed on the OGC side. Is Mickaël with us?
Yeah, Michel, you're on the stage. Could you just speak to us? We can see you online,
Yes.
but not in the room.
Yes, do you hear me?
Yep, you're very faint in the room. Shall we switch presenters?
That's okay. I think we'll get a technician. In the meantime, I think we should invite on stage our friends from CCCC. Very happy to have them here, and they'll give us an update on their views around what should be done around serving exchanges of information for emerged tunnels. We have a great example, by the way, of an emerged tunnel here in Oslo, the one that goes underneath the opera, the new opera. Agent.
Thank you for infrastructure room. Thank you, Michel. Thank you, John, for addressing our last minute request. Give us this 10 minutes slot. So thank you again. And we take this opportunity to introduce this new project that's proposed. It is an immersed tunnel project. As we sense, there is a consensus that internationally quite a lot of interested partners is going or currently working on this area. So as you can see, we're working with AEC3, Roy Hatkening, who are presenting here. Yes, sorry, yeah. And we gradient principle, so they are going to working on that internally to organize resources to allocate to these projects. And okay, so we are now open for more interested partners. So after today's presentation, although it's only 10 minutes, but we are going to keep it open, asking for more interested partners to come to contact us. Okay, so without further ado, I think to you, we can start the presentation.
Okay, thank you. Next, I'm going to present our proposal for immersed tunnel project. Since it's a new project in buildingSMART, so it's also saying our hello world today. So our new proposed project is called the immersed tunnel, and also I'm so glad to hear that there's already existing immersed tunnel in Norway, and we are from CCCC. We have been building a couple of immersed tunnel in China because we have many rivers, lakes in China. So the immersed tunnel has a good adaptability and adaptability to the environment, because we do not need to make a bridge to cross the lakes, so we can just make an immersed tunnel. And also, as we know, the ocean takes 70% on the Earth, and maybe in the future, maritime can be our new development area. So that's the good timing that we can start a immersed tunnel project. And I think we're gonna have a constant relationship between immersed tunnel project and our IFC tunnel projects. In this slide showing there's the real project happening in China. For example, the Hong Kong Zhuhai Mackellar Bridge. There are 2 immersed tunnel there. It's already built up, and the car can run through it. This slide is also showing the process when we are building the immersed tunnel. The picture on our left corner is the longitudinal view of a immersed tunnel. So it's just lying in the under the seabed. Also, we have creating 5 topics under our eMERGE Tunnel project. The first part is making the data exchange requirements, which is always the starting point when we are making a IFC project, which is also the very important part. The second part is unified data structure, because we are trying to make a digital copy of the eMERGE Tunnel from physical world to the virtual world. So we need to make the data structure as unified. And also in these parts, we are not making it by our country standard or by our company standard. It's a universal standard. So also today we call more members together because we want to make it a global data structure that can be used everywhere. The third part is IFC data exchange. IFC data exchange, because IFC not only used for storage but also used for exchanging the data between disciplines, between the processes. The fourth part gonna be verification software developments. Because IFC standard is one layer. If we want to use it, we have to land it down to the software or hardware, then people can use. So before we release it officially, we need to verify it. And the last part gonna be engineering project verification. Just as I said, we CCCC have been built a couple of eMERGE Tunnel project in China, so we have some experiences. So in this part, we can bring our experiences from the real world, from engineering projects all the way to the FC standard developments. And also, on the other hand, we believe that FC standard and the open beam philosophy can help our project to be better in the future. And that's the rough timeline of our eMERGE Tunnel projects, starting from this year, 2023, and to 2025. Okay, I think that's all my presentation today, and hoping we can have more members together. We can hand in hand to make our project great. Thank you.
Thanks very much. Thank you. So we're going to try and get Mickaël back on, and we're going to see if we can get his sound coming through our speakers better. So Mickaël, I'm going to bring you onto the stage. Yep, you're with us again, Mickaël. I don't know if you could speak to us, please.
Yes, do you hear me?
Oh, you're much louder now. Thank you.
Wonderful.
Yeah. So we're going to go ahead with, if you just want to introduce yourself, Mickaël, I'll bring your slides up while you're doing them.
So, hi everyone, my name is Mickaël Beaufils. As Michel introduced me, I'm from the Geological Survey of France, BLGM, and I would like to report on some activities we have in order to connect what was done in the IFC tunnel, still done in IFC tunnel, regarding geotechnics, and an activity we have in OGC in order to align those definitions for what is geotechnics and how the geotechnical data shall be shared in GIS and BIM. So the project I'm speaking about is called the Geotech Interoperability Experiment, Geotech IE. That's something we dreamed of in 2019, about an idea that all geotechnical engineers should speak the same language, hopefully, and try to describe their data the same way. So our idea was, okay, we should have some project in which most of the geotechnical engineers should be able to come, and they will express what are geotechnical data, how they should be described, and we will try to provide some common tools, APIs to make that connection happen, and also provide some guidance. So the dream came true on February 2022. We started this activity, and it's still ongoing. We are in the way to close it, but it's still ongoing, and I will report on where we are now. Here is an overview of all the activity we address. So, common conceptual model in order to align the semantics. As we have some extension of IFC done by BSI IFC tunnel, we have also extension of OGC geoscience standards that are performed. And we have some activity of implementation, show that what we define can also be implemented with some OGC API. I will go further on that. And we also have some guidance that are both technical and also some for software vendors in order to see how they could take benefits of OGC standards, how they could use OGC APIs in order to expose the data. So that's the goals of Geotech IE, and I will focus on the right part, so some more technical things about the extension of GeoGC standards and also these APIs. A first thing you have to know that we have a wiki, and like buildingSMART International, we work on GitHub, so you can enjoy what we are currently doing and have an overview of it. Thanks to that link. So that's ongoing activities, so everything is not finished, and very adjustment and progress are very prone to happen every day, to be honest. So then I'm going back to my topic of today, OGC standard extension. We identify several things that should be done in the OGC standards. So especially we have the capacity to cover geology and hydrogeology description, but geotechnics was something to be proposed. So we identify some specific concepts to address. Also, there are properties regarding geotechnics that should be proposed for existing geological and hydrogeological concepts. So we list them, identify them, and we propose them. But the thing I would like to speak about is about the very central concept that is a borehole concept for the geoscience community, and in which we identify that there would be nice things to do because, yeah, most of the data we use from geotechnics come from boreholes, and we have to properly describe them in order to have some fine data to be used then for the models and interpretation. So we started an experimentation that was about exposing borehole data with some OGC API. So we address both topic about the semantics, what should be the right way to describe a borehole and what is inside a borehole or what can be extracted from a borehole. And we design an API in order to expose this specific data with the idea that this API should be accessible from both BIM environment and GIS environment. So in order to show that this API could be interesting, we tested it with some geotech tests. They are called CPT, SPT pressure method for the specialists in the geotechnical engineers. And yeah, it was a use case for us in order to show that this technology can work. So I'm going to much in more details. Yeah, before going to what we did, some more words about with who we try to do that. You may have heard about some other geotech standards called AGS and DIG. So the first one is from the UK, the second one is from the US. And what they have their own community and they already expose their data. So first one from kind of CSV file and the second one with some kind of XML file. And so they know pretty well those tests. And the idea was in that project to see how we can expose AGS and DIGS data with this API. So this will enable people from that community to figure that, yes, this technology can be helpful, and there will be a connection with what they already done. So this activity was an iterative process. So we discussed with them what were their requirements, and also it enabled to validate our solution. And so what was done was basically some mapping between existing files of data they have, on which we try to them to the data model we design together, and that will be used in order to expose this kind of data. So our 5 use cases are listed here, and the idea is that there will be more use cases because we believe that the solution we design would be nice enough to address other kind of tests. So this will happen in after Geotech IE in another group that I will present just after. Some UML model. It's about the way we expose the data, the way this API is designed. So the idea is, well, you have your objects, you can map it, you can have it on a map, on a GIS tool, or in a 3D model, in a BIM software. And and from what you see, you will be able to access to those APIs that will give you the observation measurements that were made. So that's the idea. So I will not go into details of that models, but you can see there are 4 main parts. So the one on the left, up left, is about users' projects for asset management. The idea is that you can control who can access to what, depending on the projects and the roles of the users. You have on the right hand description, test description, so what was performed, and also the results. And on the bottom part, you have information about the borehole color and trajectory. So it can be either a point on the map or either a wall trajectory, hopefully in 3D. And you have also the path that was followed by the modeler or the interpreter in order to get those observations. So information regarding provenance, such as the sampling procedure, the preparation procedure. So you can have those information accessible that enable to link the data together. So this unique data model is the one that can be used for CPT, SPT, all the tests we imagine and tested. And you have different way to access to it. So if you have your borehole color as a point, yes, you will access the data from that BH color thing. If you have a 3D representation of the trajectory or 2D representation of the trajectory, then you will access from the trajectory. And if you would like to see what happened inside the borehole or from a sample you identify, then you can also enter the model from that gate. So that's a very brief description of what this tool can perform. You have a link here to this tool, so you can test it if you want, but it's still in development. And BRGM will be one of the first to use it for its own data. So that's it for the presentation. So as a summary, we started in 2022. We expect to end this year. We have some mapping activity between those 4 nice standards organizations that address geotech. We show that OGC APS can be quite nice for that. We will write a lot of guidance in order to guide you in that journey, and we have a website that can be used from that. And the last point, I mentioned that there will be a group that will follow the activities of Geotech IE and also can follow the activities of BSI. It's this TC222 of ISSMGE, so about geotechnical BIM and digital twins. So ISSMGE, well, if you know ITA for tunnels, that's the equivalent for geotechnics. It's the scientific society for geotechnics. So we have a group about geotechnics, and we can propose some activities that can be extending the capacity of addressing more and more tests. That would be a nice thing to follow. And we have a meeting and hopefully a workshop that will happen in Lisbon in August 2024. So if you are a fan of geotechnics, you can, yeah, we can meet there. Thanks for your attention, and if you have some question, I'm happy to answer them, or you can contact me with this email address.
Mickaël, thank you very much. Given we are a little bit short on time, I think we should jump into the presentation by the software vendors. John, if you can try to launch it.
Okay.
I'll save you a few seconds.
Let's
get ready. With this initiative jointly with OGC, we are sort of trying to, of course, bridge GIS and BIM. That's a use case in a sense. Geotechnics is a big use case, but that's a use case in a sense. And I'd like to take this opportunity of this introduction to speak about the session that takes place at 4 o'clock in that room, right, Mark? Yes. Whereas a group has been set up to try to take a little bit of a broader perspective on how we can help people deal with GIS data and BIM data in the context whereby you would consume GIS data, you would develop your project into BIM, and you would re-inject into GIS what has been built, what has been encountered in terms of subsoil considerations, for example. So this loop that we know is a bit cumbersome today to deal with as an engineer, making sure that the geotechnician and the civil engineers deal together well. Is that I should stop here? Okay, I do.
All right.
In this video, I would like to show you the progress of Akka software implementation of the tunnel standard. We used the BSI report in order to create a model that allows to see the standard in action. In particular, we can see that we started by modeling 2 different alignments, one for the railway and one for the tunnel. Next, we divided the tunnel into its special zones. And in order to decide which special structure decomposition to use, we referred to the buildingSMART report. In particular, the report proposes 3 possible approaches: the large, medium, and small scale. For our particular example, we used the medium scale in order to decide the best special structure. What this means in practice is that the tunnel is divided into its portal, medium pushing behavior, and pushing behavior. Each one of these tunnel parts is then subdivided into spaces, again as suggested from the buildingSMART report. So each one of these spaces is then further subdivided. Particularly, we have the line, internal, drainage, and track spaces, which in turn are then divided into further spaces. And finally, we have the objects themselves. What we wanted to demonstrate with this example is that, thanks to the use of the new IFC standard for tunnels, it's possible to start from drawings and create and model the tunnel in a very accurate way. Here, we can appreciate the geometric level of detail. But let's not forget that each single object is also rich in data information, so with its own attached properties. In order to accomplish this, we used the approach of the decomposition. So we have used assembly of assemblies in order to create each single piece of object. This allows to have a very accurate geometry and a very accurate decomposition of the model. This, for example, opens up the possibility to have a very accurate bill of quantities and quantity takeoff. So far, we have only had a look at the structure of the tunnel, But here we can also have a look at the modeling of the drainage part. This has also been modeled in a very accurate way and also opens up to new use cases, such as, for example, the possibility of code checking and clash detection. Again, here we can see that each single object has been modeled on its own, up to the single board of the tunnel. Here we can see how we can, for example, navigate the tunnel in a first-person view in order to see how the construction is evolving. And here we are looking at how it's possible to decompose the tunnel in different ways. Here, for example, we are using the grouping mechanism in order to group up similar objects. And last but not least, it is possible to deploy the OpenBIM IFC model directly on the GIS system. This is very important because it allows the GIS system to query the information needed for the spatial queries directly from the IFC model in order to have results that are as much accurate as possible. With this, I have shown you how ACCA is implementing the new IFC tunnel standard. Thank you very much for your attention.
Esri continues to advance ArcGIS as a scalable 3D system of record that allows AEC professionals to create, store, manage, and share content across the life cycle phases of built assets. Having joined buildingSMART International as a multinational member in May 2020, Esri continues to strengthen integration support of design files through its flagship 64-bit desktop GIS application, ArcGIS Pro. GIS professionals use ArcGIS Pro to conceptualize designs, share design alternatives, and deliver spatial data for planning, design, building, and operating the built environment. Direct read capabilities in ArcGIS Pro allow BIM and CAD file datasets to be consumed while remaining in their native formats without the need for conversion. BIM datasets stored in IFC files, Autodesk Revit files, and 3D CAD files from Bentley's MicroStation can be federated together with other sources of design data and GIS data for visualizing and analyzing physical infrastructure in real-world contexts encompassing both the built and natural environments. Web scene content can be published using ArcGIS Pro for viewing and interacting through a web browser. In this way, GIS, BIM, CAD, and IFC data can be viewed by other project stakeholders and even the wider community through comprehensive 3D web scenes. Through the adoption of software libraries maintained by the Open Design Alliance, of which Esri is a founding member, direct read integration support for IFC files in ArcGIS Pro remains aligned with advances to and versions of the IFC schema. Both complex geometry and rich attribution of the IFC schema are accounted for, where the current release of ArcGIS Pro, version 3.1, supports file reading through IFC 4.3 release candidate 4. Esri's ongoing development efforts for GIS BIM interoperability include support of new concepts and usages arising from BSI's IFC tunnel project. For example, integration support is underway for expanded georeferencing options. We're also providing a voice and delivering value back to the IFC tunnel project team, where we have performed quality assurance as part of testing consumption of project test models, and also informed the documentation updates to IFC schema entries pertaining to assignment of coordinate systems. Through Esri's continued voice and integration support for the latest advances in the IFC schema, the ArcGIS 3D system of record will likewise continue bringing new possibilities for analysis, visualization, and cross-team collaboration to GIS professionals, designers, and project stakeholders for building better and more sustainable communities.
Hello, my name is Gregory, and I'm a developer at RailComplete, which is a software used for developing railway. And this is our IFC tunnel testimonial. So, why are we interested in IFC? For example, it helps us import alignments, which we then can use to add information such as signals or sleepers. We can then export this information to IFC, and then this information can then be further processed by other software. And it has also become a requirement by railway administrations to use IFC. So, how did we improve our IFC export capabilities? So, from the IFC tunnel project, we received an overview of concepts in IFC that are also applicable to railway. And also from the IFC rail project, we received valuable testing data. So, what is the purpose of this video? Here, we will demonstrate RailComplete with our new IFC export, and then in the end, we will summarize some key takeaways and discuss future work. So, a typical task of RailComplete would be to import alignments and then export sleepers and rails. So, in this case, we have actually been given alignments from the IFC rail community. We have imported them into RailComplete and created objects based on these alignments. Here we can see information on the RailComplete objects. So, in total, the alignments are 37 kilometers. So there are quite a lot of sleepers and rails that will be created. We would now like to export the sleepers and rails to IFC. So here we can select which IFC version that we'd like to export to. And here we can check if we'd like to include alignments in our export. We then click export. Here we see the result, 56,000 entities. It can be opened in the Open IFC viewer. So if we zoom out here, you can see the entities and the tracks. And you can also see the structure of the project, which has been divided into railway parts containing rails and track elements. So, with the help from IFC Tunnel and IFC Rail, we have optimized our IFC export. In this case, we use the concept object typing and map geometry. And this let us reuse the geometry for each sleeper. So instead of specifying the geometry every time you have to create a new sleeper, we just refer to a type which has a geometry. And this also makes the file more interpretable for IFC software. So the final file size of the IFC file containing 56,000 entities became 50 megabytes. And if we had not implemented these concepts and reused the geometry, the file size would quickly reach 10 gigabytes. So, what are the future tasks? We'd also like to implement advanced geometries that would make the file size smaller and the file more interpretable. And we'd also like to improve our exchange of chainage information, which is hugely important for our import. And we'd also like to introduce the concept of reference alignments in our IFC exchange. Thank you for your attention.
very much for the opportunity to provide an update on what's happening with Sequent and Bentley in terms of IFC tunnel and the use of IFC in our tunnel design workflows. Sorry that we can't be there in person with you. That would have been great, but unfortunately we're unable to. So here's a short update prepared by myself and my colleague Gregory from Bentley. So just a reminder, Sequent is the Bentley subsurface company. So we are part of Sequent, but we deal with everything to do with the subsurface, geotechnical engineering and so on, while Bentley is the engineering software company and obviously deal with engineering design of built structures, asset management and so on. So together, tunneling is a natural point of intersection for Sequent and Bentley to work on solutions for the industry. And just to give you some product perspective, here are the main products that are involved in our digital tunneling workflow. So we have geological modeling with Leapfrog, tunnel BIM design with Open Tunnel Designer, and geotechnical analysis with Plaxis. And of course, we've got iTwins for digital twins and asset lifecycle management. So Open Tunnel Designer really sits at the heart of this workflow. And we'll just explore a little more on how we're using IFC in this context. So if we dig in more detail into the workflow, taking more of a granular look, what we're going to highlight here is the use of IFC to exchange the geological model from Leapfrog Works and take it into Open Tunnel Designer. And then we can take the complete BIM tunnel design together with the soil layers out of Open Tunnel Designer using IFC also. So that's the areas that I've highlighted here in the blue boxes, and we'll just have a. So here we are in Leapfrog Works. So this is where we construct our geological models and build them up for providing our site conditions into the tunnel design. To provide this geological model to Open Tunnel Designer, we can export out in IFC, and so this is what we're doing right now. It's very simple, and that's going to pick up all the different layers, all the different fault blocks, and export them out in an IFC file. Then, if we go over to the Open Tunnel Design environment, we can bring that into Open Tunnel Designer. So we do this by importing the soil layers, selecting them out of the file, bringing them in, and so that's what's happening here at the moment. And not only is Open Tunnel Designer importing those layers from the IFC, it's also then cutting the tunnel model through those layers to kind of create the intersection between the two models. Then we can take the whole model in its entirety and export it again out to IFC. So that's what's happening here, and Open Tunnel is using an Open Design Alliance component under the bonnet to actually kind of create these outputs and bring those inputs into Open Tunnel Designer in the first place. So if we pick up that output from Open Tunnel Designer and we open it up here in a BIM viewer, in this case we're using BIM Vision, and it loads up the whole model. It's relatively large because, you know, as you can see, we've got the entirety of the site extents, including the geological model, but here we see those same geological model volumes as we had them in Leapfrog. And this model, as we peel back the layers, we can see also contains that tunnel design model that was created in Open Tunnel Designer. So this then becomes you know, kind of more of a federated model provided in IFC format for your project.
and we've got all the tunnel lining and the reinforcements and all the components of the built tunnel as intended sitting here in this environment. So it's been really great to be part of the IFC tunnel project. As you can see, we're using IFC formats in the exchange of data within our workflows at the moment. The very observant amongst you will see that we're not yet using the new IFC tunnel schema, but we look forward to continuing to develop this workflow and supporting the industry with the adoption of open standards. So thanks for the opportunity to provide an update here, and I look forward to catching up with many of you in the future after the summit. Thank you.
Explorer view, you find the design tasks and import-export tasks. We open the tunnel design window from the tunnel design task. In the inner profile dialog, you can specify the shape of the tunnel cross-section. The tunnel is connected to the road through the road surface edge lines. The perimeter rock surface can be defined as a standalone cross-section or an offset of the inner profile. Niches and cross tunnels can be defined as well. The 3D model of the tunnel is created in CAD. You open the associated CAD software from the lower right corner of the system. Inside the CAD software, you choose the null point tunnel menu and click on the 3D tool button. In the 3D dialog, you can specify the tunnel elements you want to export and the change interval. When the 3D tunnel is drawn, you can rotate and inspect the result. Finally, you export the tunnel as a DVG file. Back in Quadre, we import the DVG file you just saved. In Quadre, all the data is stored as objects. Therefore, you need to convert the CAD layers to data objects in the import process. This is done by conversion rules. You can view the imported tunnel part in 3D by right-clicking on the import task and choose View in 3D. The second tunnel part that is already imported can be dragged into the view as well. The two tunnel parts are viewed and inspected before we start the IFC export process. The first step in the export process is to select the two tunnel parts to be exported. We choose the IFC format and open the settings dialog. On the first tab, we specify the IFC version, the project name, the author, etc. On another tab, we can specify data sets, which is a new entity type in IFC 4.4. The spatial breakdown structure is defined by an editable association file. This rather unfriendly solution will be replaced by an interactive graph tool in the future. Here you can see how the two tunnel parts are defined. In the IFC export process, the Quadre objects must be converted to IFC entities. Let's see how the conversion rules are set up. The tunnel design-based object in Quadre is converted to an IFC underground excavation entity with object type set to tunnel design base. Tunnel in the profile in Quadre is converted to an IFC arch element with predefined type lining. When all the conversion rules are defined as we want them, we finish the export task by specifying the IFC file name and location. We can use Open IFC Viewer to check the exported IFC file. In the Object Explorer, we can inspect the spatial breakdown structure to check if it is as we expected it to be. We find the two IFC tunnel parts, the tunnel base as IFC underground excavation, and the inner lining as IFC arch element. And this concludes the demo from Trimble.
Welcome. Adam and I will demonstrate how some of the IFC 4x3 tunnel workgroup setups are working within 12D model. So now we'll just go straight to the demonstration for you within 12D model. So what we have here is three views that are typically used in 12D model. There's a perspective view, which is showing all of our data. We've got an alignment, a drainage network, and a tin. In the plan view, we're just showing the drainage network and the alignment, and we've got a profile view where we're looking at the alignment. Now, with the alignment, we'll be writing information from that out to the IFC semantics. So we'll just click on the alignment string to show you what that information will be, and this goes straight to the semantic definition. That means people will be able to read it in exactly. So in this case, we'll be sending out lines, arcs, transition, natural path law in this particular case, and then we also have the vertical data. And in this case, we're using a parabola and also a circular arc inside it and grades. So that'll go out into the IFC file, semantics. Right, now we also have other areas that can show how we set it up, where we've got basically what we call setting up attribute groups. And under tags, we've got things like our spatial structure. So we can define all our spatial structure, and then various structures we apply to elements. So for example, we've got down there like water container partial. So if we go to look at our drainage network, you'll see that it actually has been tagged with that information. It was a water container and different parts of different things. Now we also have other things like in their classifications. So we set these up for UniClass. So an example here for the tin, we've actually given that the UniClass classification. So just to show how it is on the element. And so the classification there, it's gone with it. So the same idea, we can apply the classification to any of the elements. So it's actually got the UniClass information from that particular classification. Other areas that we've got in there, you can see is there's external documentation. You can have external data sets that you are working with. And also another one that you might be familiar with, the map coordinates. We'll just go up to map coordinates. This is where we set up all information, and some of it will be used depending on what information we want to write out. And we'll come to that in a second. So now we'll actually write out the data. So for that, we just have an option which has a whole lot of things you can set, because people want to write out different things. So we've got our IFC now. This is a general tab, so we'd say we pick IFC 4x4. But we have other tabs in there. One of them is for units. And in this case, we can pick what units. We have everything in radians, but we'll write it out in degrees into the file. Similarly, there's a project tab. And a lot of that information, like project documents and so on, with classifications, you can say whether or not you want that to be written out. Another tab there is a placement tab. In this case, this is used that information we have for georeferencing. So if we say pick local to map coordinates, that'll then create an IFC map conversion scale, which will use the various information from this panel. If we use map coordinate to map coordinates, in that case, it'll write it out as an IFC rich operation and just use the translations that are in there. So if we actually now write out the data, writing out that file, so we'll just write it out, and we'll get Adam to open up the file and just go through what's actually in it.
Yep, thank you, mate. So as you can see, we've got our IFC file here that we've written out. We've got our projects at the top here. We're in IFC 4x4. We've got our unit assignment, and we've got our conversion-based unit to go from degrees to radians. You can see here we've got our projected CRS and map conversion scale, which is defining the map coordinates for the project. So you can see here the eastings and northings and all the scale information here. We've got our classifications, that we set up for Uniclass. And here's some of those options that we had there ticked on. So we had the document information, the dataset information, some library information, and element type that we set up. We've also got the spatial structure stuff at the end here that we can have a look at. We've got a couple of IFC sites to define our spatial structure. So here at the bottom you can see we've got our water container partial and our site. And in our site we've got our tin that we had there in the geoscience model. So it's the tin here. And we can see here the classification reference that we set up for the tin. The code to ABC.123. Yeah, thank you. Oh, yep. Here we've got some groups here as well there, and you can see we've got a point here that's in two separate groups, and we've got our tin there in a separate group as well with that point. Yeah.
Thank you, Adam, and so thank you all for watching our demonstration.
Thank you.
So I think I need to free you up for coffee. Marek, are you calling for coffee? But I hope this proves to you that future looks somewhat brighter, given the commitment that those software vendors have already showed. I want to thank them, of course, for the time they've injected into implementing those concepts. So early on, as I said earlier, 4.4 is not yet an official release, but very consolidated still, I believe, at least solid enough for those software vendors to have started implementing. So, and they are helping us, refine things. So, thanking you for your time today. Inviting you for the session at 4 around GIS and BIM, which I think is of pretty interest. Thank you very much. Have a great coffee. Cheers.